If you have an equation like 3x plus 2 is equal to 47. Now, this is an algebraic equation where we have a variable x which is unknown. We're asked to find the variable. So, we're asked to find x. In equations like this, the first thing we do is to collect like terms. To collect like terms. And in order to collect items, meaning we are going to put the numbers which have x on one side and the one which do not have x on the other side. What do I mean? We have 3x plus 2 is equal to 47. We have x, a number with x on this side. We have 1 without on this side. So I can take this 2 to the right hand side. So we have all numbers that do not contain x on the right hand side and one which contain x on the left hand side. So to do that, we simply subtract 2 from both sides. So that becomes 3x plus 2, subtracting 2 from the left hand side will be equals to 47, subtracting 2 from the right hand side. We can now say that in the bracket we have 3x plus 2 minus 2 is equals to 47 minus 2 gives us 45. 2 minus 2 is equivalent to 0, so 3x is equals to 45. Now we have that 3 multiplied by an unknown number x is equal to 45. To get x, we divide both sides by 3. So dividing both sides by 3 we have 3x divided by 3 is equals to 45 divided by 3. 3x divided by 3, 3 divided by 3 will give you 1, so that x is equals to 45 divided by 3 is equivalent to 15. And that becomes our answer. Moving on to something more complex, we have x minus 2 divided by x minus 3 is equals to 5. Now, this algebraic equation involves fraction. So, whenever you have an algebraic equation that involves fraction, be it the fraction being an unknown or a constant, you simply multiply both sides by that fraction. What do I mean? The denominator of this fraction in this case is x minus 3. I need to make it a linear algebraic equation where we do not have fractions, so we can work better with our terms. So if I multiply both sides by x minus 3, I will have x minus 2 multiplied by x minus 3 divided by x minus 3. That will be equals to, I also multiply the right hand side by x minus 3. So the effect will cancel out and we do not change the algebraic equation overall. So in this case now, x minus 3, they can cancel out. This was the aim in order to make the equation linear and no longer having fractions. So we have x minus 2 becomes 5x minus 3. We can use the for method to open the bracket, meaning 5 multiplied by x minus 3 multiplied by 5. That becomes 5x minus 3 multiplied by 5 will give us 15. Now, opening this, we have x minus 2 is equals to 5x minus 15. As we did for the first question, we're going to take collect like terms. We're going to collect like terms. Alright, we're going to take x to the left hand side and we're going to take the constants to the right hand side. To take x to the left hand side, I will subtract 5x from both sides. So first, we'll subtract 5x from both sides. That's x minus 2 minus 5x will be equals to 5x minus 15 minus 5x. So x minus 2 minus 5x, x minus 5x is going to give us minus 4x. So we have minus 4x minus 2 become equivalent to 5x minus 15 minus 5x. 5x minus 5x give us 0. So what we have left is minus 15. So now we have our terms x on the left hand side. Now we want to make the constants to be on the right hand side. We simply add 2 to both sides, since that's what's going to make here 0. We have minus 2. So if we add 2 to both sides, it's going to make this left hand side 0. So we have minus 4x minus 2. We add 2 is equals to minus 15 plus 2. Minus 4x minus 2 plus 2. Minus 2 plus 2 is the same as 2 minus 2. So that's equivalent to 0. So what we have left is minus 4x, which will be equals to minus 15 plus 2 is going to give us minus 13. So that's minus 13. Remember, now divide both sides by minus 4. Dividing both sides by minus 4, that gives us minus 4x divided by minus 4 is equivalent to minus 13 divided by minus 4. So minus 4 cancel out. What we have left is x is equals to minus 13 divided by minus 4. Minus and minus are going to cancel out to give us positive. Yes, so that's equivalent to 13 divided by 4. And that's our final answer.